Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 977 titled Squares of a Sorted Array. We're given an integer array here, and our task is basically sort the square of each numbers inside this array, right? So obviously the most obvious solution in this question is basically just taking every single number here, square them, and then sort them, right? Uh, that is an okay solution, but we can achieve a more performance solution in this question, right? So when we do the squaring and then sorting solution, the sorting portion will give us a time complexity of O log n, right? But in this question, we can actually do one better and actually achieve like O of n in terms of the big O notation. So and that the key clue that we need to pay attention here is that this array here of integer is already as non-decreasing. It's already sorted for us. So for example, negative 4, negative 1, 0, 3, and 10, right? This is already a sorted array. So technically we shouldn't have to sort it again, right? Because it's already sorted for us to begin with, right? And the interesting observation that we should notice is that if we take the absolute number, we will know which square is a bigger number, right? So negative 4, if we take the absolute number of negative 4 is 4, right? And if we compare it to 10, the square of 10 will always be bigger than the square of 4, right? And negative squared is always going to give us positive, right? So using that information, right, we can know that we can use a two-pointer approach, right? We can just start comparing uh, the last index or the first index and the last index and just compare the squared value, and then we'll know which number is the biggest, right? Because for example, if I take negative 20 and then negative 1, 0, 3, and 10, for example, right? And using the information that I told you earlier, right? If you take the absolute number here, 20 is bigger than 10, right? We know for sure that a square of 20 will always be bigger than a square of 10, right? So in terms of like rearranging this and form a solution in O of n, we know that the biggest number will always be coming from either ends and then slowly move inside because it's already sorted for us, right? So it's either this number or this number will be bigger than each other, right? So we just have to compare the square and then insert them into a array, and then we should return them, right? So I know that's kind of like a mouthful, but just to summarize, the strategy that we're going to use here is a two-pointer approach. We're going to compare the square of each number, and then we're going to slowly close in to until we compare every number in this array, right? So let's jump into the code and let's see how we're going to solve this. So as always, I'm just going to check if the number is empty, the array is empty. If it's not, we can just exit for performance reason. And as always, I think in the world of Leetcode, we probably will not get an incident like this unless they specify that it is possible. But this is just a habit for performance reason. If there's nothing to calculate, let's just exit this function as fast as possible, right? So as I said, we're going to do two-pointer approach. So var start equals to 0, var end equals to nums.count minus 1, right? This is just referring to the index that we're going to use to traverse. And I'm just going to create an insertion index referring to n. So as I mentioned, the strategy that we're going to use is we're going to compare the value, the squared value at each time we go, and we're going to insert them into an array. Since we're going to compare which one is larger and then insert them, we're going to insert the numbers from the last index all the way to the first index, right? So we definitely need an array for this. I'm just going to call it results and then repeating 0 first, and count is nums.count, right? That's the only, so basically it just creates an array filled with 0, and the count of the array is basically whatever that's given to us. and then let's compare and this is just the 2 pointers. So let's see, how do we, let's call it square 1 nums of start times nums of start, right? It's just a square, and square 2 equals to nums of n times nums of n. So if square 1 is less than square 2, right? Oops. If square 1 is less than square 2, so we take square 2, because we are filling it from the last, right? The insert index is referring to the last index, right? So insert index equals to square 2, and then we have to remember to decrement the n index, because we have already taken the number from the last, right? So we are closing into the array. Or if square 1 was bigger than square 2, then result of insert index square 1 and start plus equals to 1. And at each point we also have to remember to update our insert index, right? Because we are updating from the end of the array, at each number that we take we should move back one step, right? Because we already filled that spot. So let's just decrement that. Okay, and that should be the solution actually. We just compare the squared numbers and we fill up this into this array here, this results array, and that is about it. This should give us an O of n solution as compared to the sorted solution, O log of n, so it's more performant. So let's just try and run this and hope that works. There we go, looks good. Let's try and submit this. And there we have it. That is the solution for today's problem. It's a two-pointer approach mechanism. We're just comparing the squared using the information that's given to us, which is non-decreasing. That was the hint for us that we can use or consider two-pointer approach here and not resort to the sorting solution. So as always, I hope you guys find this video helpful. If you do, please feel free to subscribe to the channel and spread the good words to your friends or any Swift enthusiasts. I'm trying to grow this channel. So I'm going to put out more contents from here on now. As always, thank you very much for your time and have a good day. Bye bye.